All right, so buckle up, folks, because we're about to dive into something pretty mind-blowing. We're talking AI, but not just the kind that churns through text or analyzes static pictures. Think bigger, an AI that actually understands the world around us as it happens, in real time, through video.
Yeah, it's like science fiction becoming reality, right? But this isn't some far-off concept. Nvidia is making it happen right now with their Reason 1 model.
Nvidia, huh? Those are the graphics card folks, right?
Yeah.
What are they doing dabbling in AI that can see?
Oh, they're way more than just graphics cards these days. They're heavily into AI, and Reason 1 is a prime example of that. It's a pretty big deal. It really shifts how we think about AI.
Okay, so color me intrigued. What exactly is Reason 1, and why should we be paying attention? That's exactly what we're digging into today. We're going to break down what makes it pick, why it's such a departure from traditional AI, and what kind of waves it's making in the tech world.
Right, and we've got a ton of info to work with. We've got the initial announcements, the details about how it chews through video input, all the stuff about its reasoning capabilities, and the really exciting part, what this could all mean in practical terms. Plus, we'll compare it to other big AI players like Gemini 2.0, delve into the architecture that powers it, check out its performance stats, and even take a peek into the future with it.
So we're talking the full deep dive here, from the technical nitty-gritty to the real-world applications, and even the potential challenges and ethical questions. We're covering it all. And maybe, just maybe, we'll even do a little bit of crystal ball gazing and see where all this might lead us. Sound good?
Sounds like a plan. And hey, while we're at it, let's tackle that big question right up front. Why is this whole AI focusing on video such a game changer? After all, AI has basically been stuck in the world of language and text for ages.
Right. Why the sudden shift to visuals?
Well, with Reason 1, Nvidia is flipping the script. They're putting visual input front and center, allowing the AI to essentially experience the world through sight, just like we do. And that, my friend, makes all the difference.
So instead of reading a description of a bustling city street, it's like the AI is actually there, seeing all the action unfold.
Exactly. It's processing the movement of cars, the pedestrians crossing, even things like the changing traffic lights, all in real time.
Okay, that makes sense. So could you give us the AI for Dummies version of what Reason 1 actually is?
Sure. Reason 1 is an AI model, but unlike those that mostly deal with text, it primarily processes video input. It might seem like a small tweak, but it has huge implications. It means the AI can understand the physical world in a much richer, more nuanced way. It's processing all that visual and auditory information, a constant stream of data that text-based models just can't handle.
So it's getting a much more complete picture, more than just words on a page.
Think of it this way. Imagine reading a recipe versus watching a cooking show. The show gives you a much more comprehensive understanding, right? You see the ingredients, the techniques, the nuances. That's what video input allows Reason 1 to do, grasp those subtleties that text alone misses.
Ah, I see. So it's moving beyond just understanding words to comprehending the full context of the situation.
Right on. And that leads us to another critical point, the importance of real-time video processing. Think about scenarios where immediate action is essential. Robotics, automation, anything where split-second decisions matter.
Yeah, that robot navigating a crowded street we talked about, it can't just sit there and ponder, right? It needs to be able to see what's happening right now and react on the fly.
Precisely. And that's where Reason 1 shines. It's built to analyze those continuous video streams and make lightning-fast, informed decisions based on what it sees.
So we've established that it can process video, but how does Reason 1 go from just seeing things to actually understanding and reasoning about them? I mean, that's a pretty big jump.
Okay, so this is where it gets really interesting. Reason 1 doesn't just identify the objects in a video, it figures out how they interact with each other and even anticipates what might happen next. Picture this. Someone's pouring milk into their coffee. Reason 1 can actually deduce, hey, the next logical step is to put the milk container back.
So it's not just recognizing milk and coffee, it's understanding the whole sequence of actions, the cause and effect, kind of like understanding the verbs of the situation, right? The actions and relationships between those objects.
Exactly. It's like piecing together the story that's unfolding in the video. Let's take another example, a car driving down a two-way street. Reason 1 can watch that car, see how it's moving relative to other vehicles, the lane markings, those solid yellow lines that mean don't you dare pass, and predict whether it's going to change lanes or make a turn. It's basically applying what it's learned about driving rules and behaviors to anticipate those future actions.
Wow, that's pretty impressive. I can already see how this could be a game changer for things like self-driving cars.
Absolutely. This enhanced reasoning ability, powered by real-time visual input, could make robots and all kinds of automated systems so much more autonomous and capable. Imagine them tackling more complex tasks in environments that aren't always predictable. We're talking potential breakthroughs in healthcare, like robots assisting surgeons with incredibly intricate procedures, or in manufacturing, with robots that can adapt to changes on the assembly line. And of course, there's the whole world of self-driving vehicles navigating complex traffic situations with even greater safety and efficiency.
So we're potentially looking at a future where robots are less follow the pre-programmed instructions and more figured it out on the fly.
You got it. Now, how does Reason 1 compare to some of those other big AI models we've heard about, like Gemini 2.0? I mean, didn't that one have some pretty impressive image manipulation abilities?
Yeah, Gemini 2.0, that was the one that could alter images based on what you told it, right?
Yeah.
Was it actually seeing those images?
That's the key difference. Gemini 2.0 could definitely do some fancy things with images, but its main input was still language. It was basically following your verbal instructions to manipulate the image. Reason 1 is playing a whole different game. It's directly processing those continuous video streams. It's like the difference between looking at a snapshot and watching a full-length movie. Reason 1 gets that much richer, more dynamic understanding of what's going on in the real world.
So one is manipulating still images based on what you tell it, and the other is actually understanding what's happening in a moving, ever-changing visual stream. That makes sense.
Right. And it all boils down to the underlying technology that powers it all.
All right, time for the tech talk. Give us the inside scoop on how Reason 1 actually works. What's the architecture like?
Think of it as a hybrid system, kind of like a super efficient two-part brain. One part is incredibly fast at processing all that raw video data. That's where the multi-layer perceptron, or MLP, comes in. It's basically a really sophisticated sorting machine for all that incoming visual information. And then there's the other part that's analyzing those patterns, making connections, and figuring out what it all means. This combo allows Reason 1 to handle a huge amount of visual data really quickly. Oh, and it's also trained on a massive and diverse data set, we're talking huge, and then it goes through these refining processes to really optimize its performance.
I also read something about Nvidia incorporating publicly available data into their development process. Is that right?
Yeah, that's another cool thing about Reason 1. Nvidia has taken a really collaborative approach by using data from open source projects. A good example is the DeepSeek R1 model, which they use for something called supervised fine-tuning. It's basically like showing the AI a bunch of examples where it made mistakes and then correcting it so it learns and gets better over time. It's a great example of how the whole AI community can work together to push the boundaries of these models.
So it's like crowdsourcing intelligence, but for AI. I dig it. But with all this high-tech wizardry, how well does it actually perform? And what does the future hold for Reason 1?
Well, the early results are really encouraging. In some specific tasks, it's already performing close to the accuracy levels of some of the big names out there, like OpenAI. But where it really shines is in tasks that require a good grasp of the physical world and how things interact. You know, those complex scenarios that involve physics and real-world dynamics.
Makes sense, given its focus on visuals and the physical world. There was a quote I came across that sums it up pretty well. NVIDIA's Reason 1 marks a pivotal moment in AI, moving beyond text to real-time understanding of the world.
I like that quote. It really gets to the heart of what makes this so groundbreaking. It's not just a small step forward, it's a fundamental shift in how we think about AI.
Okay, so we've got a decent handle on what Reason 1 is and why it matters. But let's go deeper into the mechanics of how it uses video to actually reason. Can you walk us through that process?
Sure. Let's start with the basics. Video is basically a continuous stream of visual information, much like what our own eyes are taking in all the time. This constant flow allows the AI to perceive movement, actions, and interactions as they're happening, which leads to more accurate and timely decisions.
So it's not treating video as a series of still images, right?
Yeah.
It's recognizing the flow.
Exactly. It uses algorithms to break down the video into individual frames. Then it analyzes each frame, identifying the objects and their current state. Are they moving? Are they interacting? And so on. Remember our milk pouring example. The AI can pinpoint the person, the milk container, the coffee cup, along with their positions and what they're doing in each frame.
And being able to identify those objects is key to understanding the whole scene, right?
Absolutely. Once it knows what those objects are, it can start figuring out the context. Is it daytime or nighttime? Is the scene indoors or outdoors? These visual cues provide crucial context that informs the AI's reasoning process, leading to better decisions.
You also talked about the idea of smaller tasks or steps within a bigger action. How does Reason 1 figure those out?
It learns by watching those sequences of actions, by analyzing how those identified objects and their states change over time. Imagine watching someone making breakfast. The AI might see them reach for an egg, tap it on the edge of a bowl, and then pick up a whisk. It's seen similar sequences in tons of other videos, so it learns to recognize these as subtasks, steps that contribute to a larger goal, like making scrambled eggs.
So it's kind of like it's building a visual encyclopedia of everyday actions.
Yeah, something like that.
Hey.
And going back to our milking coffee, reason one learns the typical order of events: grab milk, pour milk, and then based on what it's learned from all those other videos and the physical context, put the milk container back. It wasn't specifically programmed to do that. It figures it out based on all those observed patterns.
So it's like it's making logical deductions based on the visual clues it's getting.
Precisely. Let's go back to the car on the street. The AI is observing the car's movement, the positions of other vehicles, and the lane markings, all those visual signals. And it's interpreting those signals to figure out if it's safe to change lanes or if it needs to stop for a pedestrian, all while keeping in mind those traffic rules it's learned.
It's like that quote we mentioned earlier. The internal reasoning process of reason one mimics human-like understanding by predicting subsequent actions from visual context.
It really does. It's about anticipating what will happen next based on what's happening now.
Can we get a couple more examples of these trial runs in action, just to really nail it down?
Sure, we've talked about pouring milk, leading to putting the container back. Another one would be watching someone get ready to drive, opening the car door, getting in, buckling up. Reason one can deduce that the next action is probably starting the engine and driving off. It's learning those connections between visual patterns and expected outcomes.
Okay, that makes sense. So what's going on inside reason one that allows it to do all this dynamic analysis of video streams? What's the magic formula?
It's not magic, but it's pretty close. Remember that hybrid architecture we discussed earlier? That's a big part of it. It allows the AI to process that continuous video feed seamlessly. It's constantly identifying changes in the visual information and adapting its reasoning in real time. And of course, all that extensive training, feeding it tons of data, gives it the foundation it needs to interpret these dynamic scenes effectively.
So we've established that reason one can understand what's happening in videos and even predict what might happen next. But what does this all mean for the real world? What kind of future applications are we looking at with this physical AI?
The possibilities are pretty mind-blowing, to be honest. Reason one fundamentally changes how AI can Think about all the different industries that rely on understanding the physical world. In healthcare, imagine AI assisting surgeons in real time during operations, or monitoring patients as they recover by analyzing their movements and vital signs. In manufacturing, AI-powered systems could visually inspect products on assembly lines with incredible speed and accuracy, spotting defects or identifying areas where adjustments need to be made. And we've already talked about self-driving vehicles, but AI could also be used to optimize traffic flow and boost safety in our existing transportation networks.
You mentioned those self-driving cars being able to interpret traffic laws and predict what other drivers might do. That seems like a pretty crucial application.
Oh, absolutely. Being able to understand the subtle cues in traffic, when to yield, when someone might be about to change lanes, is essential for safe and efficient autonomous driving. And in healthcare, imagine an AI that's monitoring a surgery and can detect tiny changes in a patient's condition, changes that a human observer might miss, and then flag those critical moments for the surgical team to intervene.
That's incredible. What about using it to assess safety and efficiency in other areas?
The potential is huge. Picture an AI system that's watching a construction site in real time, identifying potential safety hazards by analyzing how workers and equipment are moving, and even predicting potential accidents based on observed patterns and safety regulations. Of course, continuous learning and updates are key here to make sure that AI stays accurate and reliable in these ever-changing environments.
So it's not just about spotting hazards. It's about understanding the context and anticipating potential risks.
You got it. This requires some seriously sophisticated reasoning ability, the ability to process complex situations and make decisions that aren't just based on what it's seeing at that moment, but also on its past experiences and learned knowledge of physical principles. Think about a person riding a bicycle. They're constantly making tiny adjustments based on the terrain, their balance, their speed. Physical AI is all about mimicking that level of real-time, context-aware decision-making.
So it's like AI is learning to ride the bike of the real world.
That's a great analogy. Now, looking ahead, what kind of trends do you think this kind of physical AI might spark?
I'm curious too. What's next?
Well, I think we'll see a lot more automation across different industries as AI gets better at handling those complex physical tasks. And with that, we'll probably see increased collaboration between industries and AI developers to create specialized solutions. And of course, as AI becomes more woven into our lives, the need for ethical guidelines and clear frameworks for how we use it becomes even more important.
Speaking of the future, what are your thoughts on how Reason 1 and similar technologies might impact our lives down the road? What's your crystal ball telling you?
Well, I think we're headed towards a future where AI is so deeply integrated into our lives that it almost feels like a natural extension of our own senses. Imagine smart homes that actually understand your habits and preferences just by watching what you do. Or virtual assistants that can read your visual cues and respond accordingly. We might even see super personalized recommendations based on a more complete understanding of how you live your life.
So AI is becoming less like a separate tool and more like an intuitive companion that's always there.
Exactly. And in areas like driver assistance, AI could significantly improve safety by anticipating driver behavior and potential hazards in real time. In healthcare, we might see big breakthroughs in early disease detection and personalized treatment plans, all based on continuous analysis of a patient's condition through video and other real-time data.
And you also mentioned the potential for advancements in the reasoning algorithms themselves, right?
Oh, absolutely. Reason One's groundbreaking use of video input is a huge leap forward in creating AI that has a deeper, more intuitive understanding of how the real world works. This shift away from purely language-based models really opens the door for AI that possesses a greater level of physical awareness, which will be essential for things like fully autonomous vehicles and robots that can truly interact with their surroundings.
So we're not just talking about AI that can think, but AI that can sense and act in the real world. Fascinating. And what about the big picture? How could this type of AI influence the global economy?
Well, the economic impact is predicted to be massive. By 2030, the AI market is expected to reach trillions of dollars. That kind of growth is going to create tons of new jobs in tech, but it also means that other industries will need to adapt and potentially reskill their workforce as automation becomes more widespread.
Wow, that's a lot to process. All right, let's bring it all together. What are the key takeaways about NVIDIA's Reason 1 that our listeners should remember?
The big ones are its focus on video input as the primary way to understand the world, its enhanced reasoning abilities that go beyond just recognizing objects, and its potential to revolutionize various sectors, from robotics to healthcare to transportation.
So this isn't just a minor software update.
Hmm.
Reason 1 really seems like a significant step towards an AI that can understand the physical world much like we do.
Exactly. It's a move toward a deeper, more embodied kind of AI, one that's less about abstract concepts and more about experiencing and interacting with the world around us.
It definitely raises a lot of interesting questions about what the future holds for AI and how we'll coexist with it. It makes you wonder what other groundbreaking advancements are just around the corner.
Well, that leads me to one final thought for our listeners to ponder. If Reason One can learn to understand the world through video, what new human skills will become most valuable in a future where AI can see and interpret the world as we do?
Something to think about, for sure. Until next time, folks.